Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hey geeks, Akshay this side. How are you guys? And welcome to another session of live mock interview. This round will be dedicated to DSA based questions mainly because that's a very important topic. We feel that so we take maximum number of interviews in that topic itself, the more we can. And I'm really happy that many students have volunteered to go through this process because they feel that they get the exact vibe of how it is, and they feel that they know how what their strength and weaknesses is at the end of the round because our mentors who interview also give feedback at the end, so which we'll also do today obviously. So I can already see some comments. Hi guys. Okay. I read all the comment. I'll try to give shout out to everyone, but right now let me introduce the guest, the student who has volunteered, and also the mentor who will be taking the conducting the whole process. The student's name is Ayush Shah, and he is from Pune Institute of Computer Technology. He is doing his BE in Information Technology from there, and he is in his third year. And the mentor who will be interviewing the student, her name is Kirti. So she's a mentor at GeeksforGeeks, and she passed out from NIT Jamshedpur, and she is also involved in creating content for other channels. So it's my pleasure to invite both of them for this process. And अमन, आई नो आज ग्रीन स्क्रीन वाला मैं सेट नहीं कर पाया जल्दी जल्दी में, तो मेरे को लगा कि आज ऐसे ही थोड़ा लाइव हो जाते हैं. हाय सचिन, हाय पुरुषोत्तम, हाय. Okay, so let's invite Ayush and Kirti, and let's start our mock interview. हाय कीर्ति, हाय आयुष, क्या हाल है?
गुड इवनिंग.
गुड इवनिंग. कीर्ति आपका म्यूट है अभी, आप अनम्यूट कर लो उसको. हाँ, हाय कीर्ति, हाय. सो मैं स्क्रीन से हट जाता हूँ अभी, एंड आई थिंक कीर्ति आप लीड ले सकते हो और आप स्टार्ट कर सकते हो प्रोसेस. थोड़ा सा माइक आप पास कर लेना अपने मुंह के, क्योंकि थोड़ी आवाज हल्की सी कम हो जाती है कभी-कभी.
ठीक
है ना? चलो ठीक है आयुष, ऑल द बेस्ट.
थैंक यू.
Hi Ayush,
हाय मैम.
how are you?
I'm good. Thank you.
How everything is going on?
It is really good now.
Are you
Currently.
nervous?
Sorry.
Are you nervous?
A little excited. Not really nervous.
Okay. Okay, so let's start with your introduction. So give me your introduction.
Yeah, sure. So I'm from PICT Pune. I'm in my third year currently, and I've been doing competitive programming since 2.5 years approximately. I've recently dived into development and more inclined towards web development in specific. Yeah, that's about it.
Okay, great. So today we are having a DSA round. Okay, so let's start with the first question. Okay, so the question is you are given a linked list of length n, and you need to rotate it anti-clockwise by k places.
Okay.
Yeah.
Could you give me an example? Like,
Yeah.
let's suppose the numbers are 1, 2, 3, 4, 5, and k is 3. What would be the output?
1, 2, the numbers are 1, 2, 3, 4, and 5.
Yeah.
And k is equals to 3. The resultant linked list will be 4, 5, and then 1, 2, 3, because we need to rotate it
Okay.
by 3 positions. Okay. So if you are not getting, I can give you a sample input output.
Yeah, sure. No problem.
Okay. So I'm sharing my screen with you.
कीर्ति अभी भी आपकी आवाज थोड़ी कम है, थोड़ी आवाज कम है, पता है?
मेरी अब ठीक है?
हाँ, आप बेटर है. या तो हेडफोन्स रिमूव भी करके एक बार देख सकते हो डायरेक्टली, अगर लैपटॉप पे आवाज आए तो वो थोड़ा इजी हो जाएगा, क्योंकि ऑडियंस में भी थोड़ा लोग कह रहे हैं कि आवाज कम है. एक बार बोलना.
एक मिनट.
हाँ.
अब ठीक है? अब आ रही है?
बेटर है. अगर थोड़ा सा तेज बोलो तो सही रहेगा, आई गेस.
नाउ इट्स ऑडिबल.
पहले से बेटर है फॉर श्योर. गाइस, ऑडियंस चैट बताना एक बार यार, ऑडिबल है, मतलब सही है, बेटर है पहले. एक बार देख लेते हैं कमेंट्स में ही ना, क्योंकि थोड़ा सा मुझे लग रहा है ना. अभी लो है, अभी भी लो है, लोग कह रहे हैं.
Okay.
यहाँ तो हेडफोन्स आके माइक काफी पास कर लो, अभी भी देखो, देख रहे हो, बेटर देन बिफोर बट स्टिल लो, अ बिट लो.
Okay. So मैं एक बार फिर से ईयरफोन से कनेक्ट करके देखती हूँ.
हाँ, एक बार कनेक्ट करके ना माइक एक बार पास करके देखता हूँ.
मैं
वैसे वी आर
ईयरफोन
वर्किंग ऑन द ऑडिबिलिटी, वो उस पे बात कर रहे हैं. You can rotate the mic around your neck and maybe थोड़ा पास हो.
और कोई बात नहीं, मैं ऐसे कर लूँगी.
हाँ.
Now it's audible.
हाँ, आप बहुत सही है, बहुत बेटर.
ठीक है. So we
हाँ,
can
ऐसे
continue
लगे.
like this. Okay,
चलो भाई,
okay,
ओके, ग्रेट ग्रेट.
okay. So I am sharing my screen. Okay.
Yeah,
So you can see question also and sample input output also. So I
yeah.
am sharing my screen. Okay. Okay, so this is the question, that is, you are given a single linked list of size n, and you need to rotate the linked list in anti-clockwise direction by k nodes. And this is the given example. Here we are given n is equals to 5, and these are the linked list elements 2, 4, 7, 8, and 9, and k is equals to 3. So basically, we need to rotate it in anti-clockwise direction by 3 places.
Fine.
So we rotated it by 3 places. So output is this: 8, 9, 2, 4, 7. And
Fine.
this is the explanation given. That is when we rotated it first time. When we rotated it first time, it will become like this. This is first, and then we rotated it second time. So this is this. And when we rotated it last time, that is third time. So this will become this. This is a resultant linked list. Okay.
Yeah,
So and this is a second input output. So you
yeah,
can
fine.
take a hint from this.
Yeah. So what I would do is I would maintain a head and I would go k places ahead in the linked list.
Okay. You are not audible. What are you saying?
Uh, am I now?
Yes. Yes. Say.
Yeah. So I would maintain a head and I would go k places ahead. K places ahead and keep that pointer there itself now for now, and then I would connect the last node to the first node, and
Okay.
then the kth place, the kth node, the next of the kth node would become null,
Okay.
and my head would then be k plus one node.
Okay, and how you will attach the first part at the end of the list?
I would just point the next of end to the very first. I would have to keep, yeah, right. I would have to keep one pointer at the head as well.
Okay, okay. So, could you tell me the time complexity and space
It would be
complexity of your?
O of n, and the space would be O of 1.
Okay, okay, great, great. So, can you code this?
Yeah, sure. I
Okay,
can
so
just,
share your screen and code this.
yeah,
So you are given a head of the linked list, and you are given a key.
okay, fine.
Okay.
Yeah, is it visible now? Yes.
Yes, it's visible.
So, yeah, so I'll be given the head of the linked list, and okay, so, and I will be given K as well, of course. And I will have to maintain a count, which will keep a track of the, the number of nodes I've visited till now. Yeah. So head of next is okay. I can do this. Count is less than k. Will I be guaranteed that the that k is less than n?
No, actually, this is the base case. That k
Okay,
can
fine.
be greater than k or less. K can be greater than n or less than n or equal to n.
So I can obviously do this thing. I can make it less than n by this. So basically, what this does is if we have if a is greater than n, then it would reduce so basically, if our size of the linked list is 5, then after 5 anti-clockwise rotation we would get the same linked list. So why
Yes,
not
yes,
just make the k less than n by that much amount of by that much
oh,
amount.
yes, yes. You're
uh,
right. Could you please zoom out your screen because it's not visible clearly?
Zoom in, you mean? I can try. Just a minute.
Okay.
Do you want me to make the font little bigger?
Yes, yes. Sure.
Okay. Is it visible now? Okay, it's too much now. Is it visible now?
Uh, some more.
Okay.
Okay, now it's visible.
Okay, so cool. Um,
What you can do, you can decrease the size of this window.
yeah, I'll try that. I haven't actually done this.
Okay, okay. Now fine.
So I would just keep going until I've reached to the kth node. I'm not sure about if count should start at 1 or 0, but I can fix that later. Now I would have to also iterate to the last node as well. This would keep the pointer towards the end, and I would also have the first count ahead. Now I will go through the linked list towards the end. Uh, so that's how I will do it. If end of next is null, then this will stop. Yeah. So this will iterate till the end of the linked list, and I just have to make the end of next equals first. And also I would have to make a head of next equals to null, and my new head will be equal to um, it will actually be equal to head of next, and this has to go right. Yeah, so this should work, I guess. Yeah. So is this good, ma'am?
Okay, this is fine. Suppose I'll give you a empty linked list. That is, head is equals to null. Then
Okay. Yeah,
it will
that
give
would.
an error.
Yeah. It would give a runtime error. I'll have to handle that explicitly.
Yes, you should
Uh,
handle
all
base
right.
cases also.
Uh, yeah. So I think this would do.
Okay, okay. So now your code is fine. Yes, I got your code, and yeah, this is fine. This will work fine. Okay. So we are done with this question. So could you explain your thought process for audience that when I gave you a question, that is you need to solve this question, how you came up with this solution? Because this solution is perfectly fine. So how you came up with this solution? So could you please share your thought
Sure,
process?
sure, definitely. So whenever I see any question, if the very first thing that I think is once my friend told that if it is an optimization question, then you should first think of a DP approach. If it's not DP, then it has to be greedy. So that's one thing. And if it's a simple question, then I try to come up with a brute force solution at first, and then um, try to optimize it based on the constraints.
Okay. Okay, great. Okay. So let's move to next question.
Yeah.
So you are given a two integers a
Okay.
and b, okay, and you need to return the integer which is having set bits on all the positions where these two integers a and b are having different bits. You got my question, or should I repeat again?
Yeah, I think I get it. I think I'll go with an example. Should I?
Okay,
I
I
mean,
can share. Okay, okay.
let's suppose if something like this happens. Then 5 is represented as 101 and 10 will be 1010. 5, 10. So here every bit has to be set here, right? Because every bit in these positions are different.
Yes.
Okay, so I'll have to return 15 then.
Yes, yes.
Okay. Yeah, so the very basic approach is go through every set bit. So what I'll do is keep a string. Would be something like I've been given two integers and
Okay. Don't write a code. Just tell me your approach.
fine, cool. So I would first convert A into its binary form and B into its binary form. Make them of same length by adding zeros to whichever number is smaller at the
Okay.
MSB positions, and then
Okay.
compare the bits and keep my answer in one more string, which would have ones at those positions which where these two bits differ.
Okay.
That's one approach, and another approach which obviously involves XOR. I would just print the XOR of both these numbers.
Okay, okay. So that's great. Second approach is fine because we just need to return a number which is having set bits on all the positions
Right,
where the given two numbers having different bits. So simply we
right,
can do the XOR. What we will do, we will just return A XOR B. So this is a one
correct,
line solution. Okay, great.
correct.
And could you please tell me the time complexity?
It would be of one if the numbers are like very small.
It will be a log of n because for XOR it will
Yeah,
go
yeah,
to
yeah,
each
okay,
bit.
yeah, right, right. For
Yeah,
XORing, we will need
it will
to.
be log of n and space complexity will be O of n.
Right, right. Yeah.
Okay, fine. Okay, so this was the question. Okay, so if I'll ask you that return the number of bits where both the numbers having mismatched bits. Basically, return the number of places or number of positions where
Mm-hmm.
both the numbers A and B having different bits.
Right. So that would be easy. I would just have to find the number with the previous question was the I would have to find that number and then return the number of bits in that number,
Yes.
right? And then so I would first find that number using AX
Okay.
or B, and then I would have to just keep dividing the number by two and check if it is one. Then if the modulo by 2 is 1, then I would increment my answer.
Okay. Great. 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 You are right. Okay. This was all about the second question. So you gave me a best approach. Okay. So now let's move to next question. Okay. So this question is based on binary tree, but in this question
Okay.
you are giving three pointers because in binary trees we are having two pointers, left child,
Right.
right child, and in this question you are having three pointers for each node.
Okay.
First is left child, second is for left right child, and third is you are given a pointer next right pointer, and for each node you need to update a next right pointer, and how you will update the next right pointer of a particular node is point to the node which is next to this node in the same level. You're getting my point?
Okay. Okay.
Okay. I-
Somewhat. I could if you could
yeah, yeah, I'm sharing my
example.
screen.
Yeah, sure.
Yes.
Yes.
Okay, so this is the question, this is the example. Wait.
Oh,
Okay, so yes, so this is the question, that is you are given a binary tree and we need to connect the nodes that are at the same level. You will be given an addition next side pointer for each node and you need to update that next side pointer, and initially that next side pointer for each node will be having a garbage value. Okay, so this is the given example, this is the given binary tree. Okay, and we need to update the next side pointer of each node. So now in 10, 10 is not having any node next to it in the same level. So 10 next will point to null. Okay, so that's why it's pointing to null. And now let's talk about 3. So 3's next right is 5. So 3's next right pointer will point to 5. So that's why it's pointing to 5. And now 5 is not having any node to next to its right. So its next right is pointing to null. Similarly with 4, 1 and 2. So basically you
Okay.
need to update the next right pointer of each node.
Yeah, fine. I got it. Okay.
Okay, okay,
I got the question.
okay.
Okay. I think what we can do first is find the level of every node in the tree, uh, and then okay. So let's suppose we are at the root now, and then
Okay.
we would just do a DFS and find all the levels of the tree.
Okay, we will find the levels of all the nodes.
Yeah, right. All the nodes of
Okay,
it,
okay,
and then at a particular level we would let's suppose for 3 and 5 we would have one written on for 3 and 5 we would have one as their level, so we have
okay.
to put 3 to 5. How would I do that? Okay, yeah, fine. So I would keep a vector of tree of the type tree node, so the node pointer.
Okay. So
And
we will.
at
Okay.
sorry.
So you were saying that we will take the count. Take that which node is having which level.
Right, we have calculated that once, and now we will take a vector of T node type, and then
Okay.
at each level we would have to just push that level into that vector, and then we can from that vector we can point those tree node the next right of all the tree nodes to the next values.
Okay. Like how we will put all the nodes of particular level into that vector.
We would have to do. Okay, so in the very first DFS, we can do that, where we find the height of the tree. So we will keep level as our parameter in DFS and the node, of course. So when we are at the same level, then we will push that node into the vector. And since we are iterating from left to right only, we are guaranteed that we will be going from so we will be filling up the vector from left to right only.
Like I got your point. Basically, you want to say that we will take a vector of vectors. I'm
Right,
right.
perfect.
Okay.
Yes,
So if at a zeroth vector, what I will store the root node.
root node,
And
perfect.
for first vector, I will store all the nodes of the first level.
At the
I'm
level.
taking level number from 0. And after doing the DFS and storing the nodes and their levels in vector of vectors, so what I will do, I will just update the next side pointer of each node.
Perfect.
Okay.
Yes,
So
yes,
your approach is perfectly fine. But here we are using vectors of vectors. Okay, extra we
yes.
are using vectors of vectors. So can we optimize our solution so that
Yeah, yeah.
we will not
Okay.
use these vectors of vector?
We won't use. Okay, I have. We won't use vector of vector. We would just use one vector for now. And since we are. Oh no, wait. Just give me a minute.
Take your time. You can use a notebook or pen also if you are
Yeah.
not able to think like this. Take your time.
Yeah, so I think I have something. We would completely get rid of vector of vectors, and so what we basically want is for every left node, we are supposed to know its right node, and for every right node, we are supposed to know uh, its left node at that particular level. How that will-
Okay, just try to think about level order traversal.
Okay, okay, okay.
Just try to think in this way.
I'm not really getting anything.
Okay, okay, don't
I
worry.
mean,
Just try to think how you do you know that how we can do level order traversal for a tree?
yeah, I mean, we just do a BFS, right? For level order traversals.
So, what particular data structure we need to use for level order traversal for a tree?
Queues,
Q. Okay. So,
queues, I guess.
just try to think because in level order traversal, what I am doing, I am just traversing each level from left to right.
Oh, right,
Okay.
right.
So,
Yeah.
and that this is I want in my solution. So,
Okay.
just try to think in a way of level order traversal.
Right. So, yeah. Right. Okay. So I think what we will do is we will do a breadth-first search. We will use queues, and we
Okay.
would push the root node obviously, and make the root node and the next right of root node null. Now we would push the left and the right parts, and while popping, we would have to pop two elements, and we would make the first element next right to be equal to um, the address of the node that we popped. We popped second, but we will also have to again push that node somehow into, yeah, okay. So we can pop one node, and we can make the next write of that node equal to the address of the front of the queue.
Okay.
I think that would do.
Okay. So, this is about first level and second level. But what about the third level?
I think
Try to think one more thing. Uh, like like we are thinking about level order traversal. Okay, so till now we got that we need to do a level order traversal. Just
right,
try to think that we need to take care of first and last node for each level, because for first node you are not having any left node, so that you can update left node's next side pointer to current node. Okay. And
right, right.
second point, we need to take care about end node, because end node next right
Yeah,
pointer will
and,
point to null. So
yeah.
just try to think level of the traversal and try to think these two steps, that is first node and last node.
Okay.
So now try to think again.
Right. So the thing you told, when we are when we will pop the left, let's suppose we are at the second level and we've put the left and the right in the queue, in our
Q.
queue of root, the left and right of root.
Okay.
We pop the first element, the left one. We point its next right pointer to the queue's front, which is the right pointer of the root, right? And now when we pop the right one, we will have to make sure that, so this, since this is the end pointer, we will have to make it null, but because if uh, we can't point this pointer to the queue's front because we will be incrementing our level now, and that's why this pointer, this should be pointing towards null now. And now we have encountered the first pointer for the third level.
Okay.
And since this is the first pointer, we will have to make it equal to, and we will have to keep track of how we will store the first and the last pointer. That can be done, I think, using a boolean. We can maintain that.
Boolean. I don't. Boolean, like how you will maintain that for changing the level.
Yeah, when we are changing the level, then we encounter a first pointer, and before changing the level, we encounter a last pointer.
Okay, I got your point, but could you please tell me that how we will maintain that boolean for each node in the queue?
So right, we will have to. So we will obviously have to keep. Yeah, so we will have to keep the level also in our queue. So the queue will be of type pair of int comma int. The first pair will contain the, no, let the queue type will be pair of t node comma int.
Okay,
So the first will contain the address of that particular node, and the second value will contain the level.
okay. So yeah, I got your point. You are saying that we will do a level order traversal, but with each node, when we are putting that node into the queue, we will take care of the level also.
Right.
And
So we will just
suppose
increment the level
yeah,
when
and
we are.
suppose I yes, and suppose I popped front node, and now I am just updating the front node's next pointer to the next
Mhm.
node. But
Right.
before updating, I need to check whether the next node is having same level or not. If it is having
Correct.
same level, I will update its next right.
Right.
Else, I will update its next right to null.
Perfect. Yes.
So
Perfect.
okay, yeah, your approach is fine, perfectly fine. Now, could you please tell me the time complexity and space complexity for this solution?
O of one both. O of n. Sorry. O of n.
Oh,
Time and place. Yeah. Sorry.
okay, okay, okay. Now I got your solution. So could you tell me your thought process, like how, so that audience go to know that how you reach to this solution?
Right.
Second
So
one, second one approach.
yeah. So the first thing you told is we have to go at each level and then update its next pointer. So that is a hint that we have to do a level order traversal. You gave me that hint, level order traversal. We just have to maintain all the levels of the node. That's the first thing. And the next, so the second approach was like you provided all the hints. So that's
Okay.
what.
So from hints, you came to come this solution.
Yeah.
Okay, okay, great. Your solution is absolutely fine. Actually, this solution is having this question is having two, three solutions.
Right.
So your solution is also fine. Okay.
I think also the
So
vector approach would have O of in both. I think I am not
okay,
sure. Yeah, I think it would.
yeah, that approach is also fine because we will use a of n because we will use each node only once. So
Correct.
time and space complexity will be of n and
Mm,
of n in that case. But in that case, we are doing DFS, so recursive approach that is taking extra memory for recursion, and
perfect.
also
Yes.
vectors of vectors we are taking. So that's why this
Right.
approach is better than that approach. Okay.
Of course. Yes.
Okay. So now let's move to next question. So you are given a binary tree and you need to print the boundary of the given binary tree. That is, firstly, you need to print the nodes in the left boundary, then you need to print the leaf nodes, and then you need to print the nodes in the right, reverse right boundary. Okay, so
Okay.
I am sharing my screen. You
Yeah.
can take a hint from that input and output. Okay.
Yes.
Okay, so this is a question, that is, we are given a binary tree and we need to find its boundary traversal,
Mhm.
and the traversal should be in the following order, that is, firstly left boundary node should be printed, and then leaf nodes should be printed, and then reverse right boundary nodes. That is, suppose we are given a tree, this is given binary tree,
Okay.
so we need to print in this order, like firstly I need to print this left boundary nodes,
Mhm.
and then I need to print these leaf nodes,
Okay.
and then I need to print these nodes in reverse order like this.
Okay. Okay.
So you will
Got it.
start from this, and from this, and then leaf nodes, and then we will move to this point. So
Got
left
it.
boundary nodes, leaf boundary nodes, and reverse right boundary nodes.
Right. Okay. Got it. Um,
So this is another example. If you want to take second one, this one.
okay. Fine. So the tricky part here is finding the left boundary and the right boundary. The leaves are pretty easy. Um, okay. To find the left boundary, what we can do is we start with the root
Okay.
and keep going left. If
Okay.
we can't go left, that is, if the left pointer is null, then we go right.
Okay.
Can I share my screen and tell you? I mean,
Okay. Okay. I am getting your point, but you can share your screen also.
okay. Okay. Okay, so the left boundary is this, right?
Yes.
So we will go left of the root if we can. Here we can't go left because the left pointer is null, so we go right.
Okay.
Here we go left because we can go here. So
Okay.
that would give me the left boundary.
Okay.
And okay, so I would have a vector which would keep the track of the left boundary first.
Okay.
Then I would have to keep a track of all the leaves. Leaves is pretty easy. Uh, all the leaves would be so if the left and the right of that uh, node is null, then it is a leaf, and we would push it in a vector again.
Okay.
Here we would have to keep something in mind that we will be already taking the very first leaf which we will encounter, so we won't store that.
Okay.
And now the part comes that we have to keep a track of the right boundary.
Reverse right boundary.
Right, so we can take the right boundary first, and then we can just reverse the array. So what I will do is, similar to what I did in left boundary, we will keep going right from the root, and where we can't go right, we will go left.
Okay. Firstly, we will try to find its right child. If it's empty, then we will move to its left child.
Left, right, right.
Okay. So, firstly, you said that for left boundary, we will store its node in a vector,
Correct.
and then we will store leaf nodes, and then we will store
The
right
right
boundary node,
boundary, but then we
and
will reverse the right boundary.
okay, okay. So and also you told me one thing that we will take care of the first leaf node. Okay.
Yes,
So
this
how we
leaf.
will take care of that thing? Could you please tell me?
Yeah, so since we are going left first always in our DFS, unless it is the right boundary, we will be storing the leaf nodes in in the order from left to right. Since we are going first, since we are DFSing first left, and then we would DFS right,
Okay.
then we will this makes sure that we will have the leaf nodes from left to right only, and
Uh,
then
uh,
we just
uh, I'm not getting your point. So firstly, we will do a DFS for left boundary only.
right,
Okay.
right. Yes,
So
yes.
basically, for left boundary, we are not traversing complete binary tree.
Correct, correct, correct.
Okay. And for right part, we are having just leaf node of right part only. That
Yes.
is one leaf we will get in right traversal, and one leaf we will get encounter in the
In the
left
left level.
boundary traversal.
Right.
Okay.
So we
Okay.
will have to basically do three DFSs, if I'm not wrong. So
Yes,
the
you are
first
right.
DFS would be for left boundary. Next DFS would be for the right boundary, and one more for the leaves. So in the case of leaves, we will have to go through all the nodes in the tree.
Okay. Great. And how now how we will print the order the desired order because firstly we need to
Right,
print left boundary nodes, then we need to
right.
print leaf nodes, and then we need to print reverse right boundary nodes. So how we will
Correct.
print that,
Yes,
because now we are having three vectors. In first vector I am having left boundary nodes, and in
yes.
second vector I am having right boundary nodes, and in
Right,
third vector I am having leaf nodes. Okay. So
right.
how now how we will print in desired order?
So first we will print the left one.
Okay.
The next we will print the leaf one, but excluding the first and the last element, because that we have taken in left boundary and right boundary,
Okay.
and then we will print the right boundary.
Okay, your approach is absolutely correct. So basically, here we are using three extra vectors. Okay,
Right, right,
so
yes,
can we optimize this approach from space complexity of n to of one? Because I want to print. We just need to print. We are not returning here. So
right.
can we print while traversing? Is there any
Yes,
way?
yes. The left can be directly printed while traversing it. There is no
Okay,
need to store in a vector.
okay,
The leaf we would have to keep a track of the first and the last node somehow. I'm not sure how we will do that now. And then we can obviously print the leaves like that only. And for the right one, we would have to keep a track of we would have to use a vector because we have to reverse the order. Wait,
okay. So here we are using DFS for right
right,
boundary. So
right,
basically, we will use recursion. So
right.
can you think of anything, any
Yes, we
concept
can.
that? Uh,
We can print in reverse order in the recursion itself. Right, you're right.
okay. So tell me that thing.
Yeah, sure. So what we will do is we are doing a DFS in the right part now. We would then for the left part we would write a C out here itself before we DFS before we call the DFS.
For
And
left part.
yes, yes, for the left
For,
part.
for left part, we just print it before calling to the next node,
Correct. Yes.
right? Okay.
Before, yeah,
For right.
before calling the DFS. For right, we would have to first call the DFS of right. If right is not null, so that's a one condition. Uh, if right is there, then we call DFS right. If not, else we would have to call DFS left, and then we would see out our node value. I think that should work. Just give me a minute. I'll try to.
Okay. Okay. Don't wait. Take your time.
Yeah. Yeah, I think this should work. So we will print the node value here.
Okay. So here, what you wrote, if okay, in else part, we will call left part.
Right,
Okay.
right. Yes.
Okay. Great. And now we are done with the left boundary. Now
Yes.
we are done with the reverse side boundary. Okay.
Right.
So now
Now
we know that how we will print that. So now
yes.
try to think that how we can print leaf nodes.
Right. So um, we will have to keep a track of the first and the last leaf. Can we do that? So I think the BFS for leaf would look like something like this. Node value, node address, comma a boolean variable which would keep a track if it is if first. Uh, yeah, I think this would do. So so if we now just give me a minute.
Okay, take your time. Don't worry. Just try to do a dry run of some small example.
Yeah, sure. Okay, what we can do is we when we are traversing the left part, we can mark the leaf there and there itself.
Okay, we will mark the leaf node that it's a first leaf node.
Yes, so when we are doing the left traversal only, we will come to the leaf and we will mark this leaf as we like. If we have taken it, you don't need to count it anymore.
Okay, so how we
Similarly on
will
the right.
okay, so how we will do that? Means how we will.
We can right. So we can maintain for every node. Do we have to maintain? No. Okay. So if we will maintain the uh, tree node address of the first leaf.
Okay,
At first it would be null, and when I have done and I'm on the leaf, then I will take this address and put it in this value, and similarly on the right.
okay, yes. So your approach will be work fine. That firstly we will print the right boundary, and also
Right.
we are printing the first leaf node, and then we will move to the leaf nodes. But when we are moving to the leaf nodes, till now we are not having right boundary nodes.
Right. Right. Right.
Because
Okay.
what was my yes, from now I got this point, that is for that we need to do firstly right traversal, right
Yes.
boundary traversal,
Yes.
but here we
Yes.
are doing
But that
right traversal. Yes, yes.
but here when so we can't print the right traversal, then we will have to maintain a bit.
Yeah, but my question is that can we do it in an optimized way?
Yes.
Uh,
So I just need to now get rid of the last leaf.
First and last leaf node. Okay.
Yeah, so the first will be taken care of. So we would do the first we would do the left traversal. We would maintain this first leaf variable, and then we would do the leaf traversal. We would check if the address of this leaf is equal to this, then don't print it. Otherwise, print it.
Okay. Okay. For
And
left
now
part, I got.
yes, now the right part is important. Okay, so when doing the right traversal only, we would not take the leaf. How we can do that is we will in the very first condition we will check if my node value sorry node of next node of left and right, if it is null, then I would directly return. I would not print it.
If node of left is null, or what if it is having its right child?
It will not be a leaf then. So So when I'm doing the right traversal here,
Okay.
I'm printing all the values, right? So, but I
Okay.
don't want to print the leaf value here just.
Okay.
So I would take here. I would take here that if my uh, nodes left and right are, if they're null, then I won't print it. Otherwise, I will print it.
Okay. Yes, your approach is absolutely correct. And this was I wanted. That's why I was asking again and again. So one more thing we
Right.
can do here is, so as you told me that while I'm traversing right boundary for right boundary nodes, what I'm doing, I'm just checking that if a current node is leaf node, I will not print it because I already printed in the leaf nodes. Okay.
Correct.
So
Correct.
and how I'm taking care of first leaf node in left boundary, and we are storing the address of the first leaf node in the first
Correct.
leaf variable
Yes.
while I'm
Yes.
doing the left boundary. So what
Yes.
we can do instead, we will not print leaf node while traversing left boundary nodes and while
Exactly.
traversing right boundary
Correct.
node. So we will
Correct.
just
Correct.
simply print leaf nodes in when we are traversing for leaf nodes only.
Yes. Yes. Right.
Okay. So
Yes.
I hope you got this thing. Okay. So your
Yes.
approach is absolutely fine. So just tell me the time complexity and space complexity.
It would be of n per time and of 1 per space.
Okay, so great. This question, you did this question very well. Okay, because you tried different approaches, and at last you came with the approach that I was expecting from you. Okay,
I took a
so
lot of time.
okay, so this was all about this interview. These were the questions. So if you have any question, you can ask me.
Okay, no, not really. I don't have any questions right now.
Okay, okay, okay. It's very good to having an interview with you. You did well.
Thank you. Thank you.
Okay, okay.
All right. Thank you so much, Kirti, and thank you, Ayush, for
Thank you
having
so
this
much.
session for the audience. And I was seeing that people were also engaging and trying to solve with the time audition which Ayush you were put in. So I think that's great. So Ayush, wish you good luck for future. I hope you'll take the whole feedback also and everything which you went through. You'll watch it again, and you'll know what can be improved and what else can be done. Right? Yeah, okay. So bye Ayush. Thank you, Jani, and thank you so much, Kirti, for taking your time
Bye.
out to do
Thank
this.
you.
Thank you, Kirti. Thank you, Ayush. Bye.
Thank you.
Bye.
Bye. Bye. All right, guys. I was seeing some feedback. Somebody wrote, Arya wrote, it's a suggestion that you engage with the audience also before moving to the next question. That's a very good point, Arya, and I'll make sure that uh, we engage more during the interview as well. But over there, Arya, the thing is that we think that okay, as it is, जैसा होता है simulation, same तरीके से हो, like not engaging in between with the audience, is completely focusing on the interview. But maybe we can try this also in any of in future webinars, so I think that's fine. All right, guys, so there's a also in the description there's a link which you can fill if you want to feature on these interviews. Also there's also one more link where you can participate in a contest which is, you can see that whether you're ready for Amazon rounds or not. It's an exact simulation of the Amazon round, so it is starting tomorrow. So just check out that link as well. Okay. So take care, guys. Stay safe. Stay at home. Get vaccinated. Akshay Bhaskar this side. Keep learning. Keep growing. And join tomorrow at 2 p.m. for a special webinar on how to leverage Twitter for your coding career. Generally, we leverage LinkedIn. We don't leverage Twitter. So about Twitter it is. So at 2 p.m. join in. And at 9 p.m. it's about Facebook, machine learning, and Facebook culture. Life at Facebook. We'll talk about that. And at 7:30 p.m. we have live mock, another live mock. So tomorrow tune in to Geeks for Geeks, and let's see कल बाकी मिलते हैं. All right, guys, take care. Bye. Akshay this side. You can join, connect me with me on LinkedIn if you want.